In this video we're going to continue our work with integration by looking at something called differential equations. The equations like the ones shown here are called differential equations. This is because they are equations which have differentiation involved in them. These are usually solved by integration. Additional information is required in order to evaluate, i.e. figure out the number for the constant of integration, c. So these are called differential equations because you can see quite clearly here that rather than just dealing with x's, we have got dy by dx. We use integration to solve these because, well, if we think about it, an equation is all about doing the reverse of operations. So we are going to reverse this differentiation by integrating. The constant of integration, we will see a little bit more about what we mean about evaluating that in the examples I'm going to do. Here's our first one. The equation of a tangent to a curve is given by dy by dx equals 3x minus 5. If the curve passes through the point 2, 4, find its equation. So we need to remember that tangents to curves are found by differentiating. So what has happened here is we have differentiated the equation of our curve and got this. I've been asked to find the equation of the curve, so I'm going to have to undo that in differentiation and integrate it to get y equals something for the equation of my curve. So I'm going to write down my differential equation. Dy by dx equals 3x minus 5. Now the important thing to understand is this is telling me the function y has been differentiated with respect to x. I want to undo the differentiation here. So the opposite of differentiation is integration with respect to x. If I integrate the left-hand side, I need to integrate the right-hand side. So this is an equation in the truest sense of the word. If I do something to one side, I have to do the same operation to the other. Now, if I integrate a derivative, it takes me back to the original thing. So that is going to leave me with just y. So y equals, I need to integrate 3x, so that is 3x to the power of 1. So that will go to 3x squared, and I need to divide by that new power. So I'm just going to do 3 divided by 2. The minus 5 will integrate to minus 5x. And then, at the end, we've got our old friend, the constant of integration. However, in this, we've been asked to find its equation. It's a specific equation here. So our friend, the constant of integration, we need to actually get rid of him. This could represent any number of curves. It could be the curve plus 1, plus 2, plus 3, plus 4, minus 7, minus 8, plus 0. This could stand for anything. We've been given a specific case. So we have got some information that we can use to find the value of c. We know x and y equal 2 and 4. I can take my coordinate and substitute it in for the values of x and y. By getting rid of the x and y and replacing them with numbers, the only variable, the only letter we'll be left with is c. So we'll be able to find his value. So I'm going to swap the y for 4. The 3 over 2 doesn't change. X, well, that's been swapped for 2. minus 5 lots of x, so I swap that out for 2 again, and plus c. 4, that isn't going to change. 3 over 2 times 4, so I've just done the 2 squared there. Minus 5 2's is minus 10, plus c. 4, still not going to change. 3 lots of 4 is 12, divided by 2 is 6. So 4 equals negative 4 plus c, which tells us that c has to equal 8. Whenever we integrate, we have to put down plus c because we don't know what the number term is. In this case, where we have been given some specific information, we have figured out what c is equal to. So this means the curve equation is this. Y equals 3 over 2x squared minus 5x, and our c is positive 8. So we have replaced the plus c with a numerical value. In this question, it was clear that this was a differential equation because it specifies here, here's a derivative, and the question leads us to realise we need to undo that. You won't always have it spelled out like this though. Derivative can be hidden behind many other words. So here I've got another similar question, but the wording's changed slightly. A curve has equation y equals fx, and it is known the gradient at any point is given by 10 cos 5x. The point pi over 10, 3, lies on the curve. Find the equation of the curve. So this is exactly the same setup as before, but rather than saying dy by dx, it's saying the gradient. So we need to realise that if this is the gradient, then this is the derivative of our original function. Now I can use either notation here. I can use dy by dx, or I can use f dash x. I'm going to go with f dash x. F dash x equals 10 cos 5x, since the gradient is given by the derivative. I don't want the derivative, I want the original function. I want to find the equation of this curve. So I need to figure out what f of x is. The way I do that is by integrating the derivative. So I will integrate the right-hand side of my equation with respect to x. So remember, what this is doing is it's basically saying undo the derivative, so this will take this back to f of x, equals. Now, we can refer to our formula list here. I have been asked to integrate cosine, so cosine will go to positive sine. So 10 cosine will go to 10 sine. We've got a coefficient, so the coefficient doesn't change, but we need to divide by that coefficient. So I will have 5x, but I need to divide by that 5. I also need to add my constant of integration. Let's tidy this up a bit. F of x equals 10 over 5 is 2. Sine 5x plus c. So at this point here, we don't have a curve, we've got a variety of different curves, because plus c could be any number. we have a point that lies on the curve we are interested in. So I know xy is pi over 10, 3. Now remember, your y coordinate, that's what your function is telling you. So f of x is represented by y here. So I can substitute this in. F of x is going to be 3 when I figure out 2 lots of sine 5 lots of pi over 10 plus c. So I have just subbed in the 3 for my y, which is f of x in this case, and I've substituted that in for my x. So I've got 5 lots of pi over 10. Tidy this up a bit. So always keep your eye out for fractions. 5 pi over 10 is the same as pi over 2. This is a non-calculator question here, just looking at that value, pi over 2. So I draw a sine curve to help me remember this. That's 2 pi, that's pi. So pi over 2 is when it has a value of 1. So I have got 3 equals 2 lots of 1 plus c. 3 equals 2 plus 1. So c has to have a value of 1. Therefore, c equals 1. So the equation of my curve is f of x, or I could say y equals 2 sine 5x plus 1. If we're lucky, we might be told that the thing we've been given is a derivative. If we're a little bit less lucky, we might be given a phrase like this. So we might be told the gradient is given by this. Or we might be told the rate of change is given by this. Or one of the other words that means differentiate. But we need to realise to work from the gradient, the rate of change, the derivative, back to our original equation, we have to integrate. So that is how we deal with differential equations.